A comprehensive guide to high availability and load balancing with AWS ELB and Spring Boot. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: Understanding high availability and load balancers. In web applications, ensuring your services are always available and can handle varying loads efficiently is crucial. High availability and load balancing are key strategies to achieve this. This podcast will delve into these concepts, mainly focusing on AWS Elastic Load Balancer, ELB, and how to set it up for a Spring Boot application. The importance of high availability. High availability refers to a system's ability to operate continuously without failure for an extended period. It is essential for applications that require constant uptime and reliability. Implementing high availability ensures that your application remains accessible even during server failures or traffic spikes. What is a load balancer? A load balancer is a device that distributes network or application traffic across multiple servers. By spreading the load, it ensures no single server becomes overwhelmed, improving responsiveness and availability. Why choose AWS Elastic Load Balancer, ELB? AWS Elastic Load Balancer, ELB, is a managed load balancing service that automatically distributes incoming application traffic across multiple targets, such as EC2 instances. ELB supports different load balancers, each designed for various use cases, making it a versatile choice for ensuring high availability and fault tolerance. Types of AWS load balancers: choosing the right tool. AWS offers 3 types of load balancers. Application Load Balancer, ALB. The ALB operates at the application layer, Layer 7, and is ideal for HTTP and HTTPS traffic. It provides advanced routing features, making it suitable for microservices and container-based applications. Network Load Balancer, NLB. The NLB operates at the transport layer, Layer 4, and is designed to handle millions of requests per second with ultra-low latency. It's suitable for TCP traffic and ideal for applications requiring extreme performance and static IP addresses. Gateway Load Balancer, GLB. The GLB integrates third-party virtual appliances with your VPC and scales them to meet demand. It is ideal for deploying, scaling, and managing virtual appliances. Deep dive into Application Load Balancers, ALB. How ALB works, a high-level view. The ALB routes incoming application traffic based on content, such as the URL path or host header. It improves availability by distributing traffic across multiple targets and ensuring that only healthy instances receive traffic. ALB's role in achieving high availability. By distributing traffic across multiple targets in different availability zones, ALB enhances fault tolerance and ensures that your application remains available even if one or more targets fail. Step-by-step tutorial: setting up load balancing for a Spring Boot app. Creating a simple Spring Boot application. Initialize a Spring Boot project. Use Spring Initializer to generate a Spring Boot project with the necessary dependencies. Create a controller. Implement a simple REST controller to handle requests. @REST controller. Public class hello controller. @getMapping/hello public string say hello. Return hello, world. Launching EC2 instances in different availability zones. Launch EC2 instances. Use the AWS Management Console to launch 2 or more EC2 instances in different availability zones. Install Java and Docker. Ensure Java and Docker are installed on these instances to run your Spring Boot application. Configuring target groups and load balancers in AWS. Create a target group. In the AWS Management Console, create a target group and register your EC2 instances. Set up an ALB. Create an application load balancer and configure it to route traffic to the target group. Deploying the application using Docker. Dockerize your application. Create a Docker file for your Spring Boot application. From OpenJDK 11. Copy target/demo.jar demo.jar. Entry point, Java, jar/demo.jar. Build and push the Docker image. Build your Docker image and push it to a container registry like Amazon ECR. Testing the load balancer. Access the ALB DNS. Obtain the DNS name of your ALB from the AWS Management Console. Test the application. Access the application through the ALB DNS name and verify that it routes traffic to different instances. Advanced ALB features. Additional configuration options. Sticky sessions for maintaining user state. Sticky sessions, also known as session affinity, bind a user's session to a specific instance, ensuring a consistent user experience. Choosing load balancing algorithms. ALB supports round-robin and the least outstanding request algorithms. Choose the one that best fits your application's needs. Defining rules for traffic routing. Set up rules to route traffic to different target groups based on host headers, path patterns, or HTTP methods. Setting up SSL certificates. Secure your application by configuring SSL/TLS certificates for your ALB. AWS Certificate Manager, ACM, can simplify this process. Conclusion, recap and key takeaways. Summary of the benefits of using AWS ELB for load balancing. Improved availability, distributes traffic across multiple targets. Fault tolerance, routes traffic only to healthy instances. Scalability, automatically scales to handle traffic spikes. Importance of high availability for Spring Boot applications. High availability is critical for providing a reliable and seamless user experience, especially for Spring Boot applications deployed in production environments. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.